Okay, welcome back to lesson 2. We're going to be talking about scientific notation. So this is what I'm going to highlight. So don't forget, at this point, you would have downloaded the lesson package 1 to 4, and you're not going back to your Google site. You're not coming back to my website to download the package again. What you need to do is you need to go to the Google Drive. Remember, on the Google Drive, you have created a SPH4C1 folder with your name on it. You're going to click into that. You're going to click onto the package that you've already used yesterday for lesson 1, and you're going to continue and scroll down to lesson 2 and keep going. If you've done it right, you should be able to see the annotated note, things that you wrote from yesterday from lesson 1 and also your worksheets. Okay? All right, so I'm going to start a new page, and I'm going to ask you, say, for examples, how heavy do you think the Earth is? Do you guys know how heavy the Earth is? Okay? I don't expect you to know this answer, but off the top of your head. But if you were to write the number, it would be all right. So 5972. Okay, this is how heavy the mass of the Earth is. Okay, I know sometimes some of you might have a questions like, oh, how do we know how heavy the mass of the Earth is? Like, we're not going to stick it on the balance and be able to find out how heavy it is, right? So scientists have indirect way of finding out how heavy things are. They use these thing called the Newton's law. Have you heard of that name? Okay, so they actually indirectly work out what are the forces and how quickly they're moving. They also use these law called Kepler's law, because planetary motion, you can actually study the time that it takes for one object to revolve around the other object, and then indirectly calculate what would the mass that would cause that force to cause this planet to move so far. But that's not what this lesson is about, right? But if you want to find out, there are all sorts of interesting things you can look at. So if I say like, oh, if I have an example and I would like you to do like, what is the mass of 2 Earth? Okay, and I'm saying, hey, take out your calculator and punch it in the calculator and get it for me. So what you would do is you would take this gigantic number and you would times it by 2. Okay, so if you want to go ahead, take out your calculator and punch it in, you won't be able to fit all the numbers in. Okay, what we do is we actually express it in terms of scientific notations. Okay, we use certain ways. Basically, the rule is right now, my decimal place is right at the end of this number, right? I'm actually going to just take these guys out so it's not confusing. Okay, so scientific notation is we take this number, this decimal place, and we are going to move it somewhere else. Do you see how I have 5972? The first number that is not 0. Our intention is, with the scientific notation, we always put it behind. We put the decimal place behind the first number that is not a 0. Okay, so what that means is I now need my new decimal place to be here. But obviously, I cannot say that the mass of the Earth is 5.972 kilogram. We know that that's not true. How do I express it so that it's true? I'm going to use an example to show you. Okay, if I say 1,000, is it fair if I say that 1,000 is really 100 times 10? Do you see that? And whenever something is times 10, we can stick an exponent and put a 1 in it. Okay, we're going to talk about that. Like, this is like the exponent rules that you learn. Okay, I can also say that 100 is 10 times 100. Are you okay with that? But 10 times 100 or 1 times 1,000. Are you seeing that these are all the same thing, right? I want my decimal place to be right here, right? I want my decimal place to be behind the 1. See what I've done? I've put it behind the 1, but I've used these tens to pretty much move my decimal place to the left and the right. And so what we do is I can now say that this is 1 times 10 to the exponent of something. Let's figure this out. This is 10 squared. This is 10 to the cube. Do you see how every time I move my decimal places, I am adding a number in front of it? Okay, so this is what the 5972 big number was. So what you do is you first of all look at the numbers that are not the zero. You stick the decimal place behind the first number that is not a zero. So this is going to be 5.972. And then you're going to write times 10 to the exponent of something. How do I figure out the exponent of something? Is we need to count the number of steps that the decimal place will have to move. Okay, my decimal place was right here behind this last zero. So I need to count how many times does it take to go behind that 5. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So this becomes times 10 to the 24 kilograms. I'm not saying the Earth is 5.972 kilogram. I'm saying that the Earth is 5.972 times 10 with 24 zeros at the end. Does that make sense? So I'm shifting the place by using the times 10, so it doesn't have to be as big. So now there's a way to punch it in the calculator that we're going to go through. Okay, so this is just the intro. Let's actually look at the note now. Okay, so why do we use scientific notation? Just now I've already demonstrated to you. We use the scientific notation to express some numbers that are very big or some numbers that are very, very small, and we're going to go into that. Okay, if this is the number 1, 2, 3, all these zeros here is written as 1.23 times 10 to the 11. Let's verify it to see if it's right. Okay, remember we have to count the starting decimal place and count to where it needs to go. And we said that it has to go right behind the first number that is not a zero. Do you see how I have 1, 2, 3? So I need the decimal place to be behind that 1. And I know my original decimal place is that last zero, right? My decimal place was here. So let's see if I actually go to this dot. Is it 11? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Do you see how they moved it 11? So that's why they stick the 11. Okay, so the words. Okay, so this is just kind of explaining the naming and the wording. I know sometimes they don't seem important, but being consistent and be able to name things the same way is important. Okay, so they call this the coefficient. Okay, and the coefficient has to be greater or equals to 1. That's why we always put it behind the first number. We don't want the decimal place to be before the 1 because it'll make it smaller than 1, right? Okay, so then they call the 10 is called the base. So this is called the base. Okay, and then I know it's base again. And then the last one is the exponent. So the 11, this number here, is the exponent. So that's just naming them. All right, so let's go through the rules again. Okay, can you try to do that? Can you first of all decide where the new decimal place is going to be? There's 4860000. Okay, we always put it behind the first number that is not a 0. So the first number in here is a 4. So that means when I'm writing this out, I need to put the dot right there. So it's going to become 4.86. I'm going to put in the base times 10, and then I'm going to count how many times do I need to move from the starting decimal place to the ending decimal places. So 1, 2, 3, 4, 5, 6, 7, 8 times 10 to the 8. All right, so the rules in here says count the number of places you need to move the decimal. Okay. How about really small number? The rule stays exactly the same. You still need to count the number of places you need to move the decimal place. But this time, when it's a really small number, instead of a positive exponent to make it bigger, we actually need to make it smaller. The same rules. Take a look at this number. Okay, it says 0.00 blah 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 732. You still put your decimal place behind the first number that is not a zero. So in this case, this 7 is the first number that is not a zero, right? Because we've got a whole bunch of zeros, the 7. So I need my new decimal place to be behind the 7. Okay, so I would write this as 7.32. I would write my base times 10. And then this time, because it's a very small number, I know that I have to stick a negative in front of it. Okay, when it's a really small number and you made it bigger, you have to actually divide it. That's what a negative exponent is. And then now I'm going to count from the starting to the new decimals. How many places have I moved? So I'm going to start from here, and I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9. So I've moved 9 places, so I'm going to write the number 9 in here. Okay, opposite to that, if I give you a scientific notation and I say, hey, move it back to the regular notation. Regular notation means the super long with a whole bunch of zeros. Okay, so they gave you scientific notation and they want you to write it in a regular. You kind of go backwards. Okay, so now what we do is we take a look at the exponent, right? We use the exponent and we move the decimal places to the right. When it's a positive exponent, you move it to the right. So I have 5.91 to start off with, but I need to move it with 6 places. So I'm going to take my original decimal place. I'm going to swing it to the right hand side 6 times. So 1, 2, 3, 4, 5, 6. See this whole bunch of spaces? Those are where I put in the 0. So I am going to write my final answer as 5910000. If you love me, if you're really good with following instructions, when you write really big numbers, it's good to space it out every 3 letters. It just makes marking so much easier, but if you couldn't, that's okay. All right, so now let's talk about negative exponents. So negative exponent, you still count, but this time you move to the left. So 2.53, I need to move it 8 spots to the left from the decimal place. 1, 2, 3, 4, 5, 6, 7, 8. My new dot is here. I fill in all these zeros. And don't forget, because this is a smaller than 1 number, I stick a 0 at the front. So 0.123, 4, 5, 6, another 0, and it should becomes like that. Okay, so you're basically just shifting. Okay, so now talking about how to punch those humongous numbers into your calculator. I don't know if we really talked about it. You do need a scientific calculator for this course. So these are samples of pictures of scientific calculator that you can get. And the button that you would be pressing are whatever the version your calculator is, it is this one. Okay, sometimes your phone has a calculator app. And if you turn your phone sideways, these things will show up too. Okay, so we're going to talk about how to use them. Hopefully we're able to do. So let's go through an example. So remember, it's either EE times 10 to the little x at the top, EXP, or the capital EXP. So let's make an example. Okay, so say I'm asking you to do 2.95 times 10 to the 5 multiplied by 3.11 times 10 to the negative 2. Okay, so say that's what I wanted you to punch it in the calculator. Okay, the easiest thing to think, it's those special buttons. Remember those buttons that we talked about? Any of these guys, right? So find it on your calculator. It's different for every calculator. I have the one on the left, so I would find the EXP button. I need you to know on the calculator what it replaces. So basically, the EXP button replaces these guys. So on your calculator, to punch it in the calculator, you literally would punch 2.95. If you have your calculator, can you follow with me? 2.95 EXP. Don't press the times. Don't press the times. You would punch it in like that. 2.95 EXP 5. And then you would press the multiplying button, because that's what this is, right? I'm multiplying it by 3.11. No multiplying this one. I'm replacing the whole EXP, or if it's EE or whatever. And then you need to find the negative, not minus. This is the negative button, 2. And then you press equal. Okay, this is not the easiest way, but I'm holding my iPad trying to take a video of how to punch it in. So follow the steps. Make sure you don't press in the times 10, the multiplication. So I'm going to show you exactly how I would do that. So 2.95. So when they say times 10 to whatever exponent, you would press the EXP button. Mine shows up to be a little E on the screen. And then I would press 5. See how nowhere in there that I punched this button in when they're within the scientific notation. So I have 2.95 EXP 5. And then in the bracket, some people like to use the bracket. I'm just going to use the multiplication sign. I'm multiplying the two number. 3.11 EXP to the negative 2. My negative button is up here. Some, like every calculator is different. So you're going to have to find yours. Negative 2. And I press the equal button. So my answer worked out to be 9174.5. So that's the answer that I got. Continuing with the lesson. Okay, let's try one more time. Okay, another example. Okay, how about something like that? You go ahead and punch it in, then you check with me what the answer is. So on my calculator, 1.19 EXP 11 divided by 2.96 EXP negative 13. 1, 3, and then, oh, sorry, that's a 5. I'm just going to change it back, sorry. 15, negative 15 equal. All right, do you see in here? I got a whole bunch of number here. And then do you see this tiny little guy times 10, 25? So the way that we would write it down on paper, I'm not going to write everything down. I say just keep 2 decimal places. I would write 4.02 times 10 to the exponent of 25. So that's where the scientific notation ending is. Okay, so to write it back down on paper, I would write 4.02. I'm not write all the decimal places, but you have to write the ending of 25 because it's actually a really, really big number. Okay, so then now I need you to do the worksheet that follows this. So the worksheet that comes with it, it says lesson 2 scientific notation. Okay, so try it out. Write your answers down. There are 3 pages. Well, I have 3 pages on mine. And then don't forget to check your answers on it, right? I'm seeing a lot of your Cami notes that are looking very colorful. They're very, very nice. Keep up with the good work. And don't forget to reach out when you have questions.